So how the equation will look like? Here you know Vg, here is your R1, R2, this point we have Vg, here you have V plus, here you have V minus. So I can write Vg is R2 upon R1 plus R2, V plus minus V minus minus V minus. So after substituting the values in the equation, Vg we have got it as minus 3.74, right? Vg we have got it as minus 3.74 volts. Using the same value equals to R2 we don't know. R1 plus R2 is given as 100 kilo ohms. Substituting as it is, V plus 5 volts minus V minus will be plus 5 whole minus 5. Now after solving you will get the value of R2. So you will get R2 as 12.6 kilo ohms. So once you know R2, you can find R1 as 87.4 kilo ohms. How we have got R1? You know R1 plus R2 is 100k. So once you know the value of R2, what you can do, you can substitute this over here and you can find the value of R1. This is how I got it as 87.4 kilo ohms. Now we are done with the half part of the design. Next is to find the resistance RD. Now looking at the circuit, in order to find this resistance we need to apply KVL from this point to this point. So for this we need to know the voltage VD, that is the drain voltage. How we can find VD? You know VDS is nothing but VD minus VS. What we can say, VDSQ is given as 5 volts and VS we have got it as minus 2.5 volts. So when you substitute, you can find VD. So VD is nothing but VDS plus VS. VDS is 5 volts and VS we have got it as minus 2.5 volts. So 7.5 volts. Now as I have shown you where to apply the KVL, looking at the diagram again, can say applying KVL to the loop indicated in the diagram. It will be V plus minus IDRD. I am redrawing the loop. Can say have resistance RD. Here you have VD and here you have V plus, which is 5 volts. Here you have RD and this is VD. It's connected to ground. VD is 7.5 volts. So when you apply KVL over here, your equation will be 5 minus ID into RD minus 7.5 equals to 0. So what you can say, ID into RD equals to 5 minus 7.5, so you will get 2.5 as the voltage. So 2.5 volts, this will give you RD as 0.5 kilo ohms. So once you are done with finding the values, you need to redraw the diagram and substitute the value. So what you can say, you have got R1 as 12.6 kilo ohms, you have got R2 as 87.4 kilo ohms and you have got RD as 0.5 kilo ohms. This is how the design is completed. You can say the maximum marks distribution in this case is for R1 and R2, because for finding R1 and R2 you need to do all these calculations. So you can say around 6 marks are for R1 and R2 calculations and the remaining 4 are for the RD, and finally redrawing the design circuit. So this is the entire designing for JFET circuit with voltage divider biasing, and the channel over here is N, so it is called as N channel JFET, right? Thank you for watching in 5 minutes.